In this video for our review for Mock 5, I am only going over the rational expressions questions, which are numbers 1 through 15. So in another video, in the second video, I'm going over the rest of the problems, which are the review. In question number 1, it's asking which two x values make the expression undefined. So again, undefined meaning anytime you have a fraction, you can never divide by 0 because that's what makes it undefined. So we're only focusing on the denominator. The denominator is what cannot equal 0. And so now we just solve for x. So here, when you solve by factoring, what two numbers multiply to get 12 and add to get -8? -6 and -2, which means x cannot equal +6 and +2. So that's why here the two answers are C and E. Now, question number 2 is asking, what is the domain? Now, if you're unsure about what this question is asking, look at the answer choices. Well, I notice that if I'm trying to figure out what the domain is in terms of real numbers that it cannot be, then again, domain is the x values. And x values, when you're looking for x values that do not exist, you're focusing on, again, the denominator. So here, the denominator cannot equal 0. So 8 minus x cannot equal 0. So 8 minus what would make 0? 8. So that's why here the answer is C. 8 minus 8 is equal to 0. Now, if you really wanted to go through and solve this, where you have 8 minus x is not equal to 0, you can subtract 8 here from both sides. So now you have -x is now not equal to -8. Divide by -1, two negatives make a positive. So that's how you can see that mathematically, or just mental math. 8 minus what is 0? 8 minus 8. Question 3 and 4, we're just simplifying here. In the numerator, can we factor that? No, that's just x all by itself. Now, if this was x squared minus 25, absolutely, I take the square root because this is a difference of two perfect squares. That's x plus 5 times x minus 5. But that's just x all by itself here. So I'm just going to bring down my numerator. So x minus 5. However, 25. But I can factor my denominator. So what two factors multiply to get 50 and add to get -27? -25 and -2. Now notice here how the x minus 25 cancels out. But notice how you have x minus 2 in the denominator, and so you're left with 1 over x minus 2. Question number 4. Again, here we're focusing on the numerator. Well, I do have a GCF. I have a GCF of not just 16, but now notice how many x's do I have at least between the two terms? 2 x's. So I can take out 16x squared. So now when I take out 16x squared, well, before I had 16x cubed, which means I still have one more x. And plus, well, 48 divided by 16 is now 3. Over then our denominator. Now, is this a difference of two perfect squares? Yes, because I have the square root. So x squared minus 9. So this becomes x plus 3 times x minus 3. Now I can start canceling out. X plus 3, and you're left with C. Question number 5 and 6 are multiplying. No need for keep, change, flip, and no need for anything really, except just start factoring and simplifying like what we did before. Well, here that's just 1, so 1 times. Now let's factor. What numbers multiply to get 24 and add to get -10? -6 and -4. Then the denominator, well, that's just m minus 4. Can't factor it, bring it down. And that's just m plus 2. Can't factor it, bring it down. So all you can simplify or cancel out our m minus 4. And so you are left with here, simplified final answer after multiplying, m minus 6 over m plus 2. Question number 6. In the numerator, now notice with this trinomial, we have 7 as our a. So we do need to do bottoms up, multiply a times c. So we're going to factor n squared plus 11n, but plus 28. Now, what two numbers multiply to get 28 and add to get 11? Well, 7 and 4. But remember, whatever you multiply by your a, now make sure to divide by that value. So this numerator is n plus 1 from 7 divided by 7 times, and then bottoms up, 7n plus 4. Now that's just 36, so I'm going to bring that down, and that is our numerator in factored form. Now we go to the denominator. Well, here that's just n squared by itself. A is 1, so I'll go straight into my factoring. What two numbers multiply to get negative 6 and add to get negative 5? Negative 6 and positive 1. Then here, can we factor 7n plus 4? No. So just bring that down and now just start canceling out. 7n plus 4 and n plus 1. So here you're left with a. Now in 7 and 8, we are now dividing. So here with dividing, we do need to do keep, change, flip. Now before we get started, I just realized there's a little bit of a typo here. So this was supposed to be, sorry, let me switch this. So 10x minus 25. And this was just supposed to be x minus 1 here. So now as we're going through and solving, keep, change, flip. So again, here I need to keep the first, so 5x minus 5, but then multiply and flip the second. So now 2x squared is now going to be in the numerator over x minus 1. Now we can go through and factor. So here I have a GCF of 5, so 5 times x minus 1, because 5 divided by 5 is 1. So now I've got 5 times x minus 1. Then here, notice how to factor, because a is greater than 1, we do have to do bottoms up. So multiplying the first to last. That means here we're going to end up factoring x squared minus 7x, but plus 10. Then what two factors multiply to get 10 and add to get negative 7? Negative 5 and negative 2. But remember with bottoms up, whatever you multiply by, now make sure to divide. So I'm going to divide both. Then here you can't divide evenly. So bottom up. So here we have 2x minus 5 times x minus 1, because 2 divided by 2 is 1. Now we're going to go to our denominator. Here I can factor, but the GCF between 10x and negative 25 is 5. When I take out 5, 10 divided by 5 is now 2, so 2x minus 25 divided by 5, which is now 5. Then here, can we factor x minus 1? No, so I'm just going to bring that down, x minus 1. Now I can start canceling out. I can cancel out the 2x minus 5s. I can cancel out the x minus 1s. And we also have 5 divided by 5, which is 1. So we are left with c, x minus 1. Now number 8 is division. So this is our fraction bar. So we are dividing. This is our first fraction that we keep. We're going to divide by. This is our second fraction that we are now going to flip. So we are going to keep 5a over a squared plus 4a minus 5. But now we're going to multiply that by, flip the denominator, the second fraction. So now 7a plus 35 is what's in the numerator over 7. Now we start factoring. Can we factor 5a? No, so I just bring that down. But we can factor 7a plus 35 because it has a GCF of 7. So times 7, and then a plus 5 from 35 divided by 7, which is 5. Now we go to our denominator. Here we have our trinomial. A is by itself, so a squared is a is 1. What two numbers multiply to get -5 and add to get 4? +5 and -1. Then here, nothing we can do. That's just 7. So bring that down. 7 times that. So now when I simplify, well, I have 7 divided by 7, which is just 1, and a plus 5. So here you're left with 5a over a minus 1. In 9 through 12, we're combining, we're adding and subtracting. So now this is, so remember when adding and subtracting, the denominators have to be the same. They have to be the same. So that means the focus here is making sure that we get them to being the same. Now, here in number 9, I noticed that, yeah, I could factor this to be 4 times r plus 1. This could factor to be 5 times r minus 1, but still even factored form, notice how they still are different. So what we're going to do here is get them to being the same. We're just going to multiply them to each other. So this is going to be multiplied as, so 5r plus 6, we're going to multiply that by 4r plus 4. We're going to multiply 3r by 5r minus 5. So now that we're going to have the same denominator, now we can go through and start simplifying. And then again, we are adding, so this is just combining like terms. So when you distribute 3r, here you end up with 15r squared minus 15r. Now notice we have 5r plus 6 times 4r plus 4. So you do have to do box method for this one. So we're going to set this up, or you can do FOIL, whatever you prefer. So 20r squared, 24r, 20r, and 24. Then of course combine your like terms. So now here we're at 44r. So our second numerator here is 20r squared plus 44r plus 24. Now all over our denominator, so now I'm going to go ahead and start combining like terms. Here I have 15r squared plus 20r squared, so 35r squared. Then negative 15r plus 44r. That now gets you 29r plus 24 over our denominator, which is 4r plus 4 times 5r minus 5. Now here, again, I'll go ahead and before we start adding and solving here, I'm going to see if I can factor. Just like how I factored here and they really didn't have anything the same, let's go ahead and do the same thing here, but with this denominator because this is just v plus 3, right? So here I notice I can take out a GCF, so that's 7v. Then you're left with v, and then 21 divided by 7, which is now 3. So now notice, this is 7v times v plus 3. Well, this denominator just has v plus 3. So what's missing for this denominator for them to be the same? 7v. We just need to multiply this second fraction here by 7v here. So nothing we need to do with the first, so I'm going to bring down 3v. But now multiply 8 times 7, which is 56v, which leaves you with combining like terms because we're adding 59v over 7v times v plus 3. Now 11 and 12, you are subtracting. Keep that in mind that you are going to end up having to distribute that negative here. Well, again, I'm going to see if I can factor. I can't do anything with x minus 7, but this is a difference of two perfect squares because I have x squared and 49. So I can factor this as x plus 7 times x minus 7. That means if this is x plus 7 times x minus 7, but this denominator only has x minus 7, what do I need to multiply this by? X plus 7. So we're now multiplying by x plus 7 here. Then I'm going to go ahead, bring down the negative 10 minus, now I've got to distribute my x here. So x squared plus 7x. Now distribute the negative. So this is actually in the numerator, negative 10 minus x squared, but now minus 7x. No like terms to combine, so I'm going to rewrite this in standard form. That is a negative x squared minus 7x minus 10 over our denominator of x plus 7 times x minus 7. That's why the answer is D. Now question number 12. I notice in the denominator, I can't factor that, and I can't factor here. So even though we're subtracting when we need the same denominator, we're just going to multiply them to each other. We're going to multiply 6 by 9r plus 3. And we're going to multiply 5 by 4r. So now here I've got 5 times 4r, which is 20r, minus, then distribute 6 here. So now I've got 54r plus 18. Now make sure, because you were subtracting, to distribute the negative. So now I've got 20r minus 54r minus 18. Combine your like terms here in the numerator. That is now negative 34r minus 18 over our 9r plus 3 times 4r. So that's why the answer is B. The last 3 questions here I'm going over with our rational are equations where we're solving. So remember now, when solving, always first focus on what are the extraneous. What makes this expression, this equation, undefined? What can x not equal? Where we focus on the denominator. So like for number 13, according to our denominator of x plus 6, x cannot equal negative 6. So we set that equal to 0 and solve. So x cannot equal negative 6. Now I notice here that I know that this is just the one fraction, the rational expression, equal to 5, but I can factor. So I'm going to always look to see if I can factor, which in this case, I have the difference of 2 perfect squares. So that's x plus 6 times x minus 6 over x plus 6, which is equal to 5. Now, what do you notice I could do here? Well, I can cancel out the x plus 6. Now I'm just left with solving x minus 6 is equal to 5. Now just solve for x. Add 6, both sides, and x is equal to 11. Now, was this our extraneous? No. X cannot equal negative 6. So x is equal to 11. Now question 14. Notice how here we're adding, so I need to make sure when adding, even within the equation, denominators are the same. And then here they're equal to a trinomial. Well, this can be factored. What 2 factors multiply to get negative 4 and add to get 3? Positive 4 and negative 1. So notice how they match. These are the 2 factors. So before I continue, what can x not equal according to our factors in the denominator? Negative 4 and positive 1. So keep that in mind. These are both extraneous. Now I'm going to get these 2 denominators to be the same here to cancel out. So I'm going to multiply 3 by, well, if it already has x minus 1, multiply 3 by x plus 4. And if 5x already has x plus 2, multiply 5x by x minus 1. Notice how the negative 21x already has both factors, so we are good to go. They will cancel out after multiplying. So distribute the 3. Now I have 3x plus 12. Then plus, we're adding, so distribute the 5x. Now I have 5x squared minus 5x, which is equal to negative 21x. Now I'm going to go through and solve. But I notice here I have like terms to combine, so let's go ahead and condense. I'm going to also write in standard form. So 5x squared But now minus 2x plus 12 is equal to negative 21x. Then because we're solving a quadratic, right, we have x squared, quadratics always have to equal 0. So that means I need to add 21x, line up the like terms, both sides. Now we're going to end up solving 5x squared plus 19x plus 12. Now, in order to solve this quadratic, because a is greater than 1, we do have to do bottoms up. So multiplying the first to last. We're going to end up factoring x squared plus 19x plus 60. And now what two numbers multiply to get 60 and add to get 19? 15 and 4. But is this our two final factors? No, because remember with bottoms up, whatever you multiply by, now make sure to divide. So this in factored form is x plus 3 times bottoms up 5x plus 4, which is equal to 0. Now we're solving for x. So this means x here is equal to negative 3 and negative 4 over 5. Now, before I box and say both are my answer, let's go back. Are either of these two extraneous? No, negative 4 and 1 were. So both are a solution. Last one, question 15. Now here, notice how you have two rational, like two fractions, right, that equal to each other, almost like a proportion. And we're solving for x. Now, I cannot factor either of these two denominators. I'm just going to go through and cross multiply. So 5 times x plus 3 is equal to 3 times x minus 9. Also, now that I have my setup and there were no other factors, I can now go ahead and also identify what makes this undefined. What can x not equal according to both of our denominators? From here, positive 9, and from here, negative 3. Now let's go through and continue. I'm going to distribute 5, so this is now 5x plus 15, which is equal to, distribute 3 here, 3x minus 27. Now notice we're not solving a quadratic, no need to equal 0 or anything, right? Because this is just solving a linear equation. So I'm going to gather my variables, subtract 3x from both sides. Now I've got here 2x plus 15 is equal to negative 27. Then subtract 15, and 2x is equal to negative 42. Then last, divide by 2. And x is now equal to negative 21. But before I box my answer and say this is my answer, is this one of our extraneous solutions? No. So we are good with this answer.